So this problem's asking us to identify what changes from the original to this function right here, the x. So this x plus 4, that means it's shifting 4 spaces to the left. So 4 units to the left, circle that one. The -2, the negative tells you two things, or the -2 tells you two things. The negative says that it's a reflection. The 2 that's out in front is a stretch. It's a vertical stretch because it's a number larger than 1. Negative is a reflection, and since it's out in front, it's not on the x, it's out in front. That's an up and down. It's a vertical reflection, up and down reflection. When you reflect up and down, that would go across the x-axis. That's what it would reflect over. So 2, 3, and 6. Just see. For end behavior, you have to look at the degree and if the leading coefficient is positive or negative. So since it's a positive and an x cubed, it's going to look something like that. So that means that the left side is going down, the right side is going up. So x goes to infinity, that's the right side. That's what this is talking about, is the right side. So on the right side, we are going up to positive infinity. So that's correct. That one's correct. These are wrong. As x goes to negative infinity, that would be the left side. This is negative infinity side to the left. The arrow's going down, which is negative infinity. So we already eliminated C and D. So between these two, as x goes to negative infinity, the left side, we're looking at the function going down to negative infinity. Number 25 here, you can just do this with a calculator. You can type it in if that's an option. So 4 minus 7i and the whole thing is squared. The calculator tells us negative 33 minus 56i. So that's obviously the right answer. Now, if you did it by hand, squared just means multiplied by itself. So it's not difficult. It's just 4 minus 7i times 4 minus 7i. And you're just multiplying. So you multiply the 4 times both of these things. And then you multiply the negative 7i times both of those things. Negative 7 times negative 7 is 49. I times I is I squared. And the last thing you would have to do is just I squared is negative 1. So that's 49 times negative 1 is negative 49. That would get combined with the 16. 16 minus 49 is negative 33. And then you combine your negative 28i and your negative 28i to get negative 56i. It's not hard to do by hand either. Finding all the zeros, you can do that with a calculator. Zeros are x-intercepts, or you can do it in the equation solver too. But this is actually really, really easy to factor. It's easier to factor than it is to type it into a calculator. So they each have an x, so factor out x. And you're left with x squared minus 4. X squared minus 4 can be factored. X minus 2, x plus 2, with the x out in front. And then zeros are what you get when you solve each of those factors. So here we get x equals 0, x equals 2, and x equals -2. A, B, and D. For this little probability question, it talks about independent events. If the events are independent, then the probability of both of them happening, probability of A and B, is equal to the probabilities multiplied together. So it is, I think it's useful to get our totals for each of these also. So like make this table a little bit bigger. There's 60 there, 60 this way, and 120 total, everything. Now, the two things that we are comparing, you can do that for all four of these charts, but the two things that we are comparing is high school student and riding the bus. So this means that we're looking for the probability of a high school student. That will be this first one. Probability of riding a bus would be the second one. And we multiply them together, and that needs to be the probability of the intersection, high school students that ride the bus. So probability of being a high school student from this one, there are 60 high schoolers out of 120. And the probability of riding a bus would be, altogether would be 60 out of 120. Multiply those together, we get something. But now we're looking at the probability of being a high schooler and riding the bus. That would be 60 out of 120. So what we're looking at with these is the probability of being a high school student that rides the bus. We're looking at that out of the total. Has to be equal to the probability of high school students times the probability of bus riders. So we're looking for probability of being a high school student and riding the bus compared to the probability of just high school and the probability of just being a bus rider. Look at all three of those things. This is like A, B, and C. 3 parts for each of these tables. So for part A, probability of being a high school student that rides the bus. That's 60 out of the total of 120 people. Did the same thing here. Probability of a high school student riding the bus. That's 0 out of 120. Probability of being a high school student riding the bus. That's 30 out of 120. Yes. And then here, this is 20 are high schoolers and ride the bus out of 60 and 60. That's 120 also. These are all out of 120 total. So that's all of our part A questions here. That needs to be the same as these other two probabilities multiplied together. So now let's do this one. I'll do this one in green. Probability of being a high schooler. How many high schoolers did they ask total here? That's 60 out of 120, half, yeah. Here we had 60 high schoolers out of 120. Here, total high schoolers, that was 60. And this one's also 60. And then the last part here is just bus rider. So when we just look at bus riders, this is 60. Bus riders, that's 60. Bus riders, that's 60. And bus riders, that's 60. So we need to look for the probability of bus equals the other two multiplied together. So which one does red equal the other two multiplied together? So this would be 1/2 equals 1/2 times 1/2. That's not it. This is 0 equals anything that's not 0. That's not it. This is 1/2 times 1/2 equals 30 out of 120 would be 1/4. This one's right. This is 1/4 equals 1/2 times 1/2. That is true. This is like 1/6 equals 1/2 times 1/2. That's not true. All right, so this one talks about probability again. We need our formula for probability. It talks about getting a B in math, not getting a B in world history, and the probability of getting a B in both. What's the probability a student will get a B in math or world history? So the key to this is identifying that first part, that it's an or. So the probability equation for or statements, we got a formula. Probability of A or B is the probability of each one added up minus the overlap. So in this word problem, the first thing that we're talking about is what's the probability of getting a B in math or world history. So this is a B in math. And this is world history. And in both cases, we're talking about getting a B. So what's the probability of getting a B in math? That's the first thing. 0.63. What's the probability of getting a B in world history? So it says the probability of not getting a B is 26, which means yes getting a B would be 7.4. And the probability that a student will get a B in both, that's told to us right here, and that's what this is saying. This is both. It's 0.39. So there's our equation. Our numbers in it, so that's all we have to do. 0.63 plus 0.74 minus 0.39. Obviously, it's not over 100. Right? Or is it? $63 plus 74 is 137 minus 0.39 is 98.98. Yeah, probabilities should never be over 100 unless there's a mistake. So that's why A was out automatically. Local gym surveys their clients about their water drinking habits. They find that the data is normally distributed, showing the mean is 64 ounces a day with a standard deviation of 4.8 ounces. What range of ounces are consumed by 95%? So for this, you need to remember that normal distribution chart and where the percentages go. Remember with this, the mean goes in the middle. And then from there, it goes out. 1, 2, and 3 standard deviations. And the percentages are broken down. So this first section of each, this is 34% here and 34% here, which puts 34 plus 34 is 68% in the middle. If you go out a little bit further than that, each of these is 13.5%. So 13.5 plus the other 13.5 is 27% added on to that. Which means going all the way out to there is 95%. And that last part would be if you went all the way out, that's 99.7%. If you go all the way out, another standard deviation. So this just talks about 95%. So that means that's within, here's our mean. And you go one standard deviation, two standard deviations each way. Two standard deviations to the right, two standard deviations to the left, that's 95%. So that's what we're going to do, is two standard deviations. The mean is 64 ounces. We're going to go plus two standard deviations and minus two standard deviations. A standard deviation is 4.8. So 2 times 4.8 would be 9.6. We're going to add 9.6 and we're going to subtract 9.6. So 73.6 is the top end. And then subtracting 9.6 would be 54.4 on the bottom end, which is B. But you need to know the percentages broken down for normal distributions. So this one talks about the different types of research. They randomly select, so that's kind of a key there. And they have the patient stay on the old half of the patients stay on the old medication, half stay on the new medication. They monitor both groups and record. It is an experiment. They controlled what medication each group was getting. They gave half the patients the old one, half the patients the new one. That is an experiment. Determine which model best fits the data and then write the model, round the values in the function to the nearest thousand. So linear, quadratic, quartic, and cubic. We want to know which one fits the best, so we are going to type in this data into your calculator. You go menu. We go to stat. We clear out whatever's already there. We're going to type in the data. So once you get everything typed in, you go to calc, regression, and we checked linear. Linear would be this first one, x, ax plus b. And we are checking, we're basically looking at the r and r squared values. R squared value, it kind of acts like, in both cases, they kind of act like a grade. This is a 88.889. That's not that great. We want that to be way higher. So I don't think it's going to be linear. X squared, that's 0.93. Getting better. Cubic, 0.989. That's even better. And then quartic, it's 1. That's like perfect. So quartic is the best. And it looks like they kind of write out our, yeah. my settings were a little bit messed up here, so I got to fix that before we look at them. My lists were switched. So my X list needs to be list 1, my Y list needs to be list 2, because that's the way I typed them in. All right, so let me rerun those. Regression, X to the 4th is 1. X to the 3rd is also 1. So we get R squared values of 1 for both of them, so let's check to make sure that the equations fit. So cubic is the one I got showing up there. 1, -2, +3. That matches. Let's check our. So C would be a good answer. Quartic. If you look, it's got a 0 for A. And it says 1, -2, 3, and then even E is 0. Which, since it has, here it has a 0 for A, but when you look at the equation for D, it has a 1 for A. Like it wrote a 1 there, 1x to the 4th. So, it is not quartic. Even though we got an R squared of 1, the equation it says 0x to the 4th should be the equation. So that's why this is wrong. So the only correct answer here is C. Because our equation that we got for quartic actually said 0x to the 4th something. Which means it's really not quartic at all. It would actually be a cubic. Because if it's 0x to the 4th, it would give us that equation. All right, same idea. We can type in this data. We're going to model it and then type in something for X to get our final answer. So here's the kind of the trickiest part of all of this. Year 2006. We have to figure out what X value that would be for our next step once we get to it. So years since 1995. So that means this is like 1996. And that'd be, this would be 98. This would be the year 2000. That'd be 2002. 9 years after 1995, that would be 2004. So 2006 is 11 years after 1995. So we're going to plug in 11 once we get the equation. But we first need the equation. So let's type in this data right here to our calculator. All right, so once you get it all typed in, we are doing a cubic regression because that's what it says in our directions. So cubic is x to the 3rd. We've got our equation right there. 0.4, 0.8, 0.1. And then this is essentially 0 because that's like move the decimal 11 spots. So 0.4, 0.8, 0.1, our equation. This would be x cubed, this would be x squared, this would be x, and then plus 0. That's our equation. And we're going to plug in 11. Now, automatically, we got this down to 50-50. It cannot be these. These don't make any sense because this is talking about thousands of trees. And it's going up. It's increasing each step of the way. This is going up. So it's not going to automatically get down to less than 1,000. It's going to be like one of these hundreds of thousands. So we're just plugging in 11 into this equation now. So you can copy it and paste it. That's the easiest way to do this. If you that only works on Casios though. When you do that, you have to select your graph. Make sure if you have anything else, you delete it. So here's our table, and you can see the numbers that we had, like 1, 1.3, 3, 18.3. That's from the table directly. That's written right there. We just want to know what you get when you go down to 11. Type in 11. You get 630.3. So it is A. 630,000. Simplifying this, you could carefully type this into your calculator and it can do it all for you. But this is actually really simple to do by hand as well. Since you have a negative inside the square root, it's going to be something with an I. And square root of 36 is 6. So that's just 6i. Square root of 49 is 7, and since there's a negative, that's 7i. And this was multiplication right here. So 6 times 7 is 42. I times I is I squared. And there's a negative right there. Out in front, we had 3 plus 4i. These are like terms. You can combine them first if you want, or you can do it later. It doesn't matter. But they're both I squared, so they can be combined. That'll be negative 42 plus 7, be negative 35 I squared. I squared is negative 1. So negative 35 times negative 1 is positive 35. And we got 35 plus 3 is 38, plus 4i, which is D. If it's a calculator question, you just type it in exactly as it's written, and you get the same answer. Calculator can do imaginaries too. But you got to be very careful the way you type it in. You got to type it in with parentheses and everything. Describe the number and type of solutions. That is answered by the discriminant. The discriminant is from the quadratic formula that inside the square root. B squared minus 4AC, the part that goes inside the square root. So in this case, we have to rewrite this real quick as 8x squared minus 3x plus 9 equals 0, so that we know A, B, and C. So B is negative 3, so we got negative 3 squared minus 4 times A is 8, C is 9. And then depending on if this is greater than 0 or less than 0 or equal to 0, tells us what we get. So negative 3 squared is positive 9, minus 9 times 8 is 72, times 4 is 100 and a couple hundred something. It doesn't really matter. This is way more than 9. What you're going to get is a negative answer. It doesn't matter what the actual number is. It's going to be a negative. 4 times 72 is 288. So that's a negative number. 9 minus 288 is definitely negative. So since that is negative, that means that you get 2 imaginary solutions. If it was positive, you would get 2 real solutions. And if it was 0 instead of positive or negative, that would be 1 solution. Positive is 2 real solutions. Negative is 2 imaginary solutions. 0 is 1 real solution. Solving algebraically, for this one, I would choose substitution. Substitute one equation into the other. Since they're both y equals, that means they end up just being equal to each other. X squared minus 8 is going to equal negative x minus 2. Get everything on one side so we can solve this, hopefully by factoring, because that's easiest. So add the x over. Add the 2 over. To get it equal to 0. This is factorable now. Has to multiply to be 6, that's 2 and 3. Add to be 1, that's 2 and 3. It needs to be positive 1 though, so we need a positive 3 minus 2. Get the signs to work out. Which means x equals 2 and x equals negative 3. We did not get a 1, we did not get a negative 2. We did not get a 1. So some of those are already gone, those can't be right. Now to figure out between these other ones, we plug in x equals 2 and x equals negative 3 to make sure that we get the right y value. So plug in 2. It's much easier to plug into that one because we don't have to do any squaring. So plug in 2, you get negative 2 minus 2. We get y equals negative 2 minus 2, that's negative 4. 2 comma negative 4. There's one of them. And then the other one, we're plugging in x equals negative 3. Negative times negative 3 minus 2. So that's positive 3 minus 2, 1, which is that one. If it was a calculator question, you could graph them both and then calculate the intersection if it's calculator, but algebraically means by hand. Determine the inverse. That's where you switch x and y. You swap them and solve it out. So swap x and y. So instead of calling this y, which is basically what that is, we say x equals the cube root of y plus 2 minus 7. And we're trying to solve for y. So the first thing we do is add 8. 7, I mean. X plus 7 equals the cube root of y plus 2. To get rid of a cube root, you raise to an exponent of 3. So those cancel out. We have x plus 7 to the third, and then we have a y plus 2 here. Finish this off, we have to subtract 2. So x plus 7 to the third minus 2. B. Initial population of 255. You know initial populations always go in the front of these forms. So that's not it, not D. it decreases at a rate of a little bit over 2% per year. If it is decreasing, that means that it is going by a factor less than 1. Increasing will be a factor more than 1. Decreasing will be a factor less than 1. This is increasing by a lot. That's like tripling. That's not it. This is increasing by that factor that it's asking for. This would be an increase. This would be 1 minus that percentage. This is a decrease. B. That's it. That's actually the only one that shows a decrease because it has to be a factor less than 1. For the sum of a finite geometric series, we need the formula. The formula we need here is A1, 1 minus r to the n over 1 minus r. So we need to know A1. A1 is the first term. R is what is being multiplied each step. So to get from -3 to 6 to -12, they're multiplying by -2. And then we're told n is right there also. So plugging all this in, we get -3, 1 minus -2 to the 7th over 1 minus -2. Just plug in A1, R, and N into all the spots into the formula. So that's -3. Our denominator, that turns into plus, so that's divided by 3, which means those 3's are going to cancel out. And this is going to be 1 minus -2 to the 7th is... So 1 minus -128 is 1 plus 128, which is 129 times the negative. Final answer is B. Jenny deposits $4,000. That is the starting amount. On all exponential formulas, starting amount goes first. Then it is earning, which means it is going up by this percent each year. So you do 1 plus that amount. So 3% will be 0.0375. Compounded quarterly. Compounded quarterly means 4 times a year, so we got to do every year. We're actually splitting that into 4. So the slightly different formula that we need here, it will be written for you. We have to divide that, since it's quarterly, we do n equals 4 here. Divide by 4 there. And then our exponent is going to be to the nt, so 4 times e, or x, whatever you want to plug in. Quarterly is 4, yep. So 25 years means we're plugging in 25 right here. So we got to punch that into our calculator. So when I type these in, I always start with the inside of the parentheses. So we've got 0.0375 for the percent divided by 4. We're adding that on to 1 because it was 1 plus for the inside of the parentheses. So there's our inside of the parentheses. That gets raised to the exponent of 4 times 25, so to the exponent of 100. And then times 4,000, that front number. So 10169. And 85 cents. So pretty much same idea here, except now it's compounded continuously, which is that E equation, P-E-R-T. So you put in $2,000, that's P. The account earns 4.88%. So that's to the 0.0488. Compounded continuously for 20 years. So you multiply by 20. That's our exponent. We just got to type it in. $2,000 times E to the make sure you put parentheses around your exponent. It's 0.0488. And 20 years, 5,307. Ooh, 29 cents or 64 cents? 64 cents. C. A and C were close. You gotta be careful. All right, given the function, we're going to find the equation of the asymptote. Now, these functions that have an exponent, 2 to an exponent, they all look like this, which means they have horizontal asymptotes. They have an asymptote that goes right there. That horizontal asymptote has to do with the vertical shift. So since it is a horizontal asymptote, that is a y equals asymptote. Horizontal lines are y equals. So we can cross those out. And then the horizontal line is based off of the vertical shift. This thing has a vertical shift of 7. That's the vertical. So it's A. So 42 logs have vertical asymptotes because the graphs look like that. The vertical asymptotes are based off of the horizontal shift. The horizontal shift on this one is to -4, left 4. So this line right here has got to be at -4. But since it is a vertical asymptote, it's an x equals, so it is C. Number 43, it has a horizontal and a vertical shift. It shifts +9 means up 9. And then that -5 means 5 to the right. Just C. Same concept here. The -6, that's vertical, so it is translated down 6. -3, that's 3 units to the right. And then the 2, it's outside parentheses, so it's vertical. Everything outside parentheses is vertical, just like this was a vertical 6. And then 2 is bigger than 1, so it's a stretch. It's a vertical stretch. Because 2 is greater than 1. The negative has to do with a reflection. And it's a vertical reflection, since this is a parabola, reflects from up to down, which that would be over the x-axis. So it's all four of those. So here we are back to probability, talking about independent. If events are independent, that means the probability of A and B equals the probability of A times the probability of B. That's all we're looking at. The multiplication has to work out here. The multiplication has to work. Choose all that applies. So probability of A times B. So we got to check and see, is 0.4 times 0.6 0.024? No, it would just be 0.24. So A is right. 0.1 times 0.5 would be 0.05. So that actually is wrong. We'll create an extra 0 in there. 0.3 and 0.2. 2 times 3 is 6. 2 decimal spots. That is correct. A and C. The multiplication just has to work out. Use your calculator if you need to multiply. Solving for logs. Main thing we have to remember is what is the base. When they don't write a number, it's 10. So if the base is 10, logs are exponents. So this 2 is an exponent. And then the rest of it's the rest of your equation, 3x minus 17. 10 squared is 100. Sucks. So finishing this off, we got to add 17. So that's 3x equals 117. Divide by 3. You get x equals 39. That's A. Similar concept right here, except we got to change everything so that they have the same base. Needs to have the same base. So 32 and 16 are both powers of 2. 32 and 16 are both powers of 2. So 32 is 2 to the 5th. Because it goes 2, 4, 8, 16, 32. And then to the x minus 1. 1 over 16 would be a negative exponent. So it's 2 to the negative 4. To the x. So we're looking at that. We multiply our exponents since we have a power to a power. So that's 2 to the 5x minus 5 when you multiply that out. Equals 2 to the negative 4th. So what matters now is that they have the same base. So those get canceled out. The bases don't matter anymore. It's just the exponents have to match up. So 5x equals, add the 5 over, you get 1. Oh, there's an x there. So it's 5x minus 5 equals negative 4x. So let's get our x's together. So that's negative 9x equals negative 5. 5 over 9 is x, so D. Average rate of change. That means these are our x's. Those are our x values. I call it x1 and x2. We need the two y values that go with it. We need to figure out y1. You get y1 by plugging in x1. Plug in x1 to get y1. Plug in -2. That's 3 times -2 squared minus 7. 3 times 4 is 12 minus 7 is 5. And then y2 we get by plugging in x2. That's 3 times 1 squared minus 7. 3 times 1 is 3 minus 7 is -4. So we get our slope. Rate of change means slope. Y2 minus Y1 over X2 minus X1. So that's -9 over 3. -3. Evaluate log base 3 of 7. Now, you can use a little bit of common sense here because this is saying 3 to what exponent is going to equal 7. It has to be a number bigger than 1 but less than 2. Because 3 to the first is 3 and 3 squared is 9. So without even using a calculator, we know it's that. If you do use your calculator, you just plug it in. You just go to your main part of your calculator. You can get log base if you want, which is in the calc menu of options. Calc. Scroll over and we can get log AB where you can type the two things in. You type in 3 and 7. It gives you that decimal. Alternatively, you type it in the other way with change of base. You just do natural log of the 7 first. I didn't mean to hit enter. Natural log 7 divided by natural log of 3. That works out the same way. You get that 1.77 number. And last one, natural log of 23. That's simple calculator question. Natural log 23. 3.135.